All right, Advanced Math 7, here we go. We've got lesson 7.2.2, coordinate geometry and midpoints. So the first thing we're going to look at is the definition of a triangle midsegment. Okay, it's just what it sounds like. It's the segment that's in the middle. It's a midsegment. So anyways, a midsegment connects the midpoints from two sides of a triangle. So this DE is a midsegment. So DE, that's a midsegment. Because here we've got a midpoint here, because D is halfway in between B and A. We know it's halfway because this segment DB is congruent to this segment AD. And we know that E is a midpoint because E is equidistant to B and equidistant to C. So it's right in the middle of BC. So we can see that DE is a midpoint because it is the segment created by two, it's the midsegment because it's the segment created by two midpoints. So D and E are midpoints. All right, so then we got two midpoints, and that makes a midsegment. Now the triangle midsegment theorem states that this midsegment is half the length of this segment down here. And it's parallel to it. So we know two things. This segment here is parallel to this other side. And we know that DE, the measurement of DE, is half of the measurement of AC. So those are the two things that we find out about a midsegment, is that it's going to be parallel to the side that doesn't have the midpoints on it, and it's going to be half the length. So if AC is 10, DE is going to be 5. And it makes sense because you're going halfway up on this one and halfway up on that one, and you're kind of going proportionate to it. So it's going to stay halfway away from here. So there's going to be a lot of halves and stuff like that in here as we go. But what we're going to do is we're going to prove on the coordinate plane that the midsegment theorem actually works. That yes, we can prove that DE is half of AC. And yes, we can prove that they're parallel to each other. So let's go ahead and do that on 7-94. So let's go ahead and make a coordinate plane here. I don't think it matters where this is. I think it's just in the first. Yeah, it's just in the first quadrant. So there we go. We've got our X and we got our Y axis. Now let's go ahead and graph these 3 points. So A is at 0, 0, so it's at the origin. So there's A at 0, 0. We've got B at 2, 6, so over 2 and up 1, 2, 3, 4, 5, 6. And then C is going to be at 7, 0. So 1, 2, 3, 4, 5, 6, 7. There we go. All right, so there is our triangle, ABC. Got it. All right, part B, what should we do now? Find D, which is the midpoint of AB. So here's AB. There's a couple ways you can do it. A lot of people just like to eyeball, but let's look at the slope of AB. AB goes up 1, 2, 3, 4, 5, 6, and over 2. So it goes up 6 over 2. So if I want to go halfway, instead of going up 6 over 2, I can just go up 3 and over 1. And there is our midpoint, D. So our midpoint is at 1, 3. Is there another way that we could do this? Yes, we could do this a different way, just mathematically. So since it's halfway, halfway is kind of like the average. So what I can do is I can take the 2 from A to B, I can take the two x values and take the average of them, and then take the y values and take the average of them. So the midpoint D could be found in this way. I could take the x values, 0 and 2, and take the average, divide by 2. And then I can take the y values of 0 and 6 and take the average, divide by 2. So here I get 2 divided by 2, which is 1, and 6 divided by 2, which is 3. And you get the same exact answer. This is just a mathematical way to do it. You don't always have the option to graph, so this is a good method to know that we can take our x values. There's actually a formula for it, for midpoints. When we find a midpoint, and let's just call it of AB. If I'm looking for the midpoint of AB, and A is at x1, y1, and B is at x2, y2, then the midpoint of AB is just add those x values together, divide by 2. Add the y values together, divide by 2. So we're just finding halfway. So you can count out the slope and go halfway, or you can actually use the midpoint formula. Same thing with E. Let's find the midpoint E, which is the midpoint of BC. So this one goes down 1, 2, 3, 4, 5, 6, and over 1, 2, 3, 4, 5. So it goes down 1, 2, 3, 4, 5, 6, and over 1, 2, 3, 4, 5. Yes, down 6 over 5. So instead we can go down 3, 1, 2, 3, and over 2.5. Right there. There's our midpoint. All right, so there's the midpoint there. So that means this is the midsegment. Okay, so let's go ahead and find that point. So that point is 1, 2, 3, 4 and a half, and then up 1, 2, 3. So that one would be at 4.5, 3. Let's prove it using the midpoint formula. So I'm going to say that E is equal to, the x values for B and C are 2 and 7. So I'm going to do 2 plus 7 and divide by 2. The y values are 6 and 0. So I'm going to do 6 plus 0 and divide by 2. So 2 plus 7 is 9, divided by 2 is 4.5. 6 plus 0 is 6, divided by 2 is 3. There's our midpoint. It's at 4.53. All right, next we're going to find the distances. So why are we finding the distance? We're finding the distance so that we can prove that this distance is half of this distance. Now, since these are horizontal lines, they have 0 slope, I can just count it out to find the distance. So counting it out, DE is 1, 2, 3 and a half. So that is 3.5 units. AC, if I count that out, that is 1, 2, 3, 4, 5, 6, 7. So what have we found out? We found out that since 3.5 is half of 7, so this tells us that DE is half of AC, which is what the triangle midsegment theorem says. It says it's half the length. So we just proved mathematically here that this midsegment is half this length. This length is 7, this length is 3.5. Next, we're going to look at the slopes. Why do we want to look at the slopes? We want to look at the slopes because the slopes will tell us if it's parallel or not. So from D to E, what is the slope? Well, let's look at the change in y over the change in x. The y is not changing at all, and the x is changing by 1, 2, 3.5. So 0 over 3.5, which is still 0. So the slope of DE is 0, and the slope of AC, it's not going up and down, so the change in y is 0, and the change in x is 7. So it still has a slope of 0. So they both have a slope of 0, so that proves they must be parallel. So here we proved that the distances had to be half. The midsegment is half of the base there. And then this proves same slope means they're parallel. Let's find the perimeters of the two triangles. All right, so triangle ABC, we'll start over here. We'll do this one in green. So triangle ABC, that's the big triangle here. We have to find out the distance of AB, the distance of AC, and the distance of BC, and then add those two together. Well, we already know that AC going this way is 7. So now let's find AB. Okay, this one goes up 1, 2, 3, 4, 5, 6, and over 2. So like we were doing on our last set of notes, that means that we can just square 2 and we can square 6. So this is 4 and 36, which is the square root of 40. Probably need a calculator at this point. Let's just round to the nearest tenth. So let's do the square root of 40. And if I hit the side-to-side button, that is approximately 6.3. So this one is about 6.3. Okay, now let's find BC. BC is going down 1, 2, 3, 4, 5, 6, and over 1, 2, 3, 4, 5. So it's going down 6 over 5, so we can make that slope triangle right there of down 6 over 5, which means we can just square 6 and square 5, which will give us 36 plus 25, which comes out to 61. All right, and the square root of 61 ends up being 7.8. All right, so if we want the perimeter of ABC, I would add up those three numbers. So 6.3 plus 7 plus 7.8 21.1. Does that sound right? Yep, that looks right. So the perimeter of that one is 21.1. Next, we'll do triangle BDE. Or DBE, it doesn't matter. All right, so let's start with B to D. Okay, this one goes up 1, 2, 3, and over 1. So for that distance, I'm going to square 3, and I'm going to square 1. So this is 9 plus 1, that's 10. Square root of 10 ends up being we'll round it, 3.2. Oh, you can't see that. There you go, see? 3.2. So that's approximately 3.2. All right, the next one we'll do DE. We already found that distance. That was 3.5 earlier. So that's 3.5. And now we'll do BE right there. BE goes down 1, 2, 3, and over 1, 2, 3. So this is going to be 3 squared plus 3 squared. So that's 9 plus 9, that's 18. So let's find out what the square root of 18 is. Square root of 18 is approximately 4.2. All right. Okay, let's add up those three together. So I've got 3.2 plus 3.5 plus 4.2, 10.9. So the perimeter of this one is 10.9. I think our rounding is making us be off by a little bit. So let's do this. So what I'm going to do is instead of rounding, I'm going to round at the end. Let's see if I get a slightly different number here. So I'm going to do the square root of 40 plus 7 plus the square root of 61. .13, blah, 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 blah. All right, let's try this one. Square root of 10 plus 3.5. Oh, dang it. All right, square root of 10, arrow over, plus 3.5 plus the square root of 18. 10.9. Let's see if I did this right. Down 1, 2, 3 over 1, 2, 3. 3 and 3, 9, 9, 18. That's right. 3.5. Good. All right, 10.9 and 21.1. Okay, so now let's find the areas. Okay, in order to find the area, remember you need to do 1/2 base times height. So let's find the area of triangle ABC. So ABC, I would use this part as my base and this part as my height. Okay, so I'm going to do 1/2. My base here is 7. And my height is, it goes up to, looks like a height of 6. So I get 21. Let's do the area of the smaller one. So this would be triangle DBE. So I'm going to do 1/2. My base here is going to be 1, 2, 3.5. And then my height is up 1, 2, 3, so times 3. Let's multiply that out. 3.5 times 3, and then divide by 2. 5.25. All right, I got to blow my nose. This is driving me crazy. I'll be right back. All right, I'm back. So I just noticed an error too. I said this was down 3 and over 3, but remember that's over 2.5. That's an error. So DE, no, BE was supposed to take the square root. I knew something wasn't going right. I didn't even notice it. All right, so 3 squared is 9. Let's see, 2.5 times 2.5 would be 6.25? I think so. 2.5 to the second power, 6.25, so plus 9. We get 15.25, so we had a little bit of mistake there. My bad. So this was 15.25. So if I take the square root of 15.25, I knew it was supposed to be half, and it didn't look right. That's about 3.9. Now if I add up these three numbers, so 3.2 plus 3.5 plus 3.9, 10.6, which is half of that. All right, so let's make some conclusions. First conclusion that we know that we have proven that the midsegment theorem works because the length of this segment is half the length of this segment. So our conclusions are that DE ended up being half of AC. Conclusion number 2, DE, we found out, was parallel to AC because they had the same slope. Third thing we found out, right here we found out that the perimeters, so the perimeter of triangle B, what are we calling it? DBE? Is equal to half triangle ABC. Because we had 21.1 and 10.6, so it's half. Now we didn't get the same thing with the area. The area, this is not half. In fact, it's 1/4. That's weird. So we find out that the area of triangle DBE is 1/4 of ABC. Now, why is it 1/4 instead of 1/2? Well, here's the reason. Think of the units. The units for perimeter are just units. The units for area are units squared, right? Area is units squared. So when I cut the perimeter in half, I have to cut the area in half twice because it's units squared. So what's 1/2 and 1/2? It's 1/4. So the perimeter will always be in the same proportion as the side lengths. But since it's 1/2, I would square 1/2 and then the area becomes 1/4 of it. Now let's say that I did 1/3. If something was 1/3, the area would be 1/9 because it's 1/3 times 1/3 because area is units squared. So if we change the units by half, the unit squared will be 1/4 because we're squaring those units. We're squaring that change. We're doing the 1/2 change twice. So if we were to quadruple, so if we were to make this 4 times bigger, the area would be 16 times bigger because we're always squaring the units. All right, that was fun. We have a little bit more to do. So this one says that M is the midpoint of AB, A's at 3,4, M's at 8,11. Okay, we want to find B. So just to make a little sketch of what's going on here, I've got A here, and then the midpoint is somewhere over here. This isn't to scale. So, oh, that's M, not A. M. So that's the midpoint. That means B needs to show up somewhere over here. All right, so if I've got A here, and it says that M's the midpoint, B should show up somewhere over here. So that means we've only gone halfway so far. So from 3 to 8 on the x's, I have increased by 5 units. So if I want to now go to the next x where B is, I'm going to have to increase by 5 units again. So the x value of B should be 8 plus 5, 13. Now for the y's, I started at 4, and it looks like I increased by a total of 7. But that's only halfway. So if I want to go to the next endpoint, B, I'm going to have to increase by 7 again. And I'm going to have to get that my y value should be 11 plus 7, 18. That would be where B is at. Is there another way to do it? Of course there is. Normally we said that with the midpoint formula, we could take the x values, add them up, divide by 2, and that equals the midpoint. So if M is the midpoint, I could take 3 plus the x value of B, divide by 2, and that equals the midpoint of 8. Right? So the x value of A, and let's call this the x value of B, because B is at xy. We don't know where it's at. So if I take the x value of A, add the x value of B, and divide by 2, that should equal the midpoint. The x value is 8. So multiply by 2 on both sides, and I get 3 plus x equals 16. Subtract 3 from both sides, I get x equals 13. Exactly what I got there. To find the y values, I'm going to say 4 plus the x value of y divided by 2 equals the midpoint of 11 for the y values. Multiply by 2, I get 4 plus y equals 22. Subtract 4 from both sides, and then get y is equal to 18. The exact same answer I got here. Both ways work. You can use either one. Okay, on a map, Carey drew a set of coordinate axes. He noticed that the town of Coiner is located at the point 3,1, and Woottonville is located at 15,7, where a grid unit equals 1 mile. If the towns want to place a school in the midpoint between them, where should it be located, and how far is it from each town? All right, let's start with where it should be located. If it's in the middle, it should be at the midpoint. So without graphing, I can solve these using this midpoint formula that we had before. So the school should be found by taking my x values of 3 and 15, so 3 plus 15, and divide by 2. And then taking my y values of 7 and 1, and dividing by 2. So that tells me 3 plus 15 is 18. 18 divided by 2 is 9. 7 plus 1 is 8. 8 divided by 2 is 4. So the school should be at 9, 4. Now they want to know what the distance is. We do know that the distance from Woottonville to the school is the same as the distance from Coiner to the school. Or we could just take the distance from Coiner to Woottonville and divide by 2. Either way works. So let's go Coiner to the school and see what distance that is. Now this is the distance formula. So we want to see the change in the y and the change in the x, and then we're supposed to square them and take the square root. So the distance is equal to the square root of the change in x and the change in y. So how much is the x changing from 3 to 15? Well, it looks like it's changing by 12. So I'm going to square that difference. Now let's look at 1 to 7. How much is it changing by? It's changing by 6. So this is the change in x plus the change in y, and then we take the square root. Remember, this is just the Pythagorean theorem. Remember, we did this on the last unit where we had a squared plus b squared plus c squared equals c squared. And we said if we want to get c by itself, all we have to do is take the square root of both sides. So c is equal to the square root of a squared plus b squared. So this is that shortcut that we were talking about in that last lesson. So here I've got 144 plus 64, which is the square root of 208, which will be 14 point something. So square root of 208 is approximately 14.4 miles. So we would expect that the distance from Coiner to Woottonville is 28.8 miles because this is the halfway point to get to the school. All right, lastly, Randy thinks the best name for the triangle is an isosceles right triangle. Okay, well, if it's isosceles right, then we need to prove that we have a right angle and that two sides are congruent. So here's what we're going to do. We're going to name our sides. Our sides are RD, side DN, and side RN. We're going to look at their slopes and their distances. Let's start from RD. R to D goes down 1, 2, 3, 4, 5, wait, 1? Gosh, why can't I do this? 1, 2, 3, 4, 5, 6, and over 1, 2. So it goes down 6 over 2. That does reduce. It reduces to negative 3. Now, if I'm doing my distance formula, I should just, if it's going down 6 over 2, I should square 6 and square 2, because this is a right triangle right there with my slope triangle. I'm just squaring these two numbers. And so 36 plus 4 is the square root of 40. We can leave it like that for right now. Okay, let's do D to N. D to N goes up 1, 2, and over 1, 2, 3, 4, 5, 6. So it goes up 2 and over 6. That reduces to 1/3. To find the distance, I use 2 and 6. So 2 squared plus 6 squared, I get the square root of 40 again. Next, we're going to do Rn. This one goes down 1, 2, 3, 4, and over 1, 2, 3, 4, 5, 6, 7, 8. So get down 4 over 8. So that's a slope of negative 1/2. Okay, to find its distance, we would take 4 and square it, and we'd take 8 and square it. Remember, I'm just using the slope triangle here to use the Pythagorean theorem. So 16 and 64 to 80. 16 plus 64. Yeah, it's 80. It's been a long day, people. All right, so have we proven that it's a right isosceles triangle? Yes, we have. We know that since these two sides have the same distance, that RD has to be the same distance as DN. Those are congruent. This is a different side length, so it's not the same. So it's isosceles for sure. Now we have to say, is this angle 90 degrees? Look at the slopes. Negative 3 over 1, positive 1 over 3. Those are opposite reciprocal slopes. So yes, that is a 90-degree angle because those are perpendicular. So yes, we can prove it. So the answer is yes. We can tell that RD is congruent to DN by the distance formula. And RD is perpendicular to DN because of opposite reciprocal slopes. The end. That one lasted longer than I wanted it to. Oh well. All right, so we are finished. One more, and then Unit 7 is over. All right, Math Hard. See you guys later. Bye.